my dear student, I'm Mr. Kitwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to study a new topic which is called the rotation of a rigid body. When we talk about the rotation, it means the motion of an object around a fixed point or around a fixed an axis. That is what we are going to see, that how some object try to rotate on it is an axis without changing their original shape. On this topic here, we shall start with a new topic which is called the center of mass. Now we are going to talk for the new subtopic which is called the center of the mass, my dear students. So before we proceed, before we go for our subtopic here, we are supposed to understand the concept of the rotation motion, to know the meaning of the rotation motion, so that we'll be able to explain about the center of the mass as the first subtopic. So once we observe here that we have the rotation motion, and when we will ask it to define the rotation motion, this is the types of motion where an object move around a fixed axis. An object tried to move around a fixed axis. This is what we say the rotation motion. If we observe an object, any object or any body, tried to rotate, tried to move around a fixed axis, that is, we say it is a rotation motion. They move without changing their original shape. They move without changing their shape. It means the shape remain constant, but they try to move, they try to rotate around a fixed an axis. We have so many examples of this rotation motion. The object that can try to move around a fixed axis. One of them is the wheeled bucket. This wheeled bucket, my dear students, they try to move around a fixed an axis without changing their original shape. Zinakuwa zina rotate pale pale. Hizi wheeled bucket, kuna ndoo zinakuwa zina uwezo wa kuwa zina rotate on its an axis without changing their original shape or their shape. That is, we say about the rotation motion. Also, we have the digital video disc, VDC. Hizi VDC, it is not a new term for you, my dear student. Once we reflect the year that the technology was not developed, most of the people, they were tried to use this disc for the aim of looking either their movie, looking at the music. Those who provided the movie, who provided the music, they tried to paste into those discs, and the people, they take those discs and they apply it for the aim of observing what they are trying to refresh their mind. Kwamba walikuwa wanatumia sasa kwenye miaka, ukiangalia miaka ya either 2015 kurudi chini, watu wengi sana walikuwa wanazitumia hizi diski kwa ajili ya kuangalia movie, kuangalia labda ni nyimbo, kuangalia vitu vyovyote vile, walikuwa wanatumia sana sana hizi diski. Ukiachia na pale kipindi kile kwamba hizi kipindi kile ukiachana hizi ni flash hazikuwepo. Kwa walikuwa wanatumia hizi ili kuweza ku observe the what they went to see. When they take this disc and put it into the instrument that receive it, when they switch on, this disc tried to rotate. Hizi disk zilikuwa zina rotate. Zinapokuwa zina rotate, wewe ndio utakuwa unaona kule movie. Kama ni movie utakuwa unaiangalia vizuri. Kama ni muziki utakuwa unaangalia vizuri kabisa, una observe vizuri due to the rotation of this disc. So this give us the concept of the rotation motion, because those disks they try to rotate without changing their shape. Kwa shape yake inakuwa ni pale pale, lakini kinachokuwa kinatokea zile diski zinakuwa inazunguka, inakuwa ipo kwenye motion, ina rotate. They tried to rotate on a fixed position, kwa sehemu fulani ambapo kuna maybe fixed. So another is the car tires. We observe, my dear student, this car tire as an example of the rigid body or the rotation motion. Why? We see most of the car. This is the example that we try to observe. Tunaona matairi haya gari, kwamba gari linapokuwa lina move, ili haya matairi yanakuwa yana move, yana rotate, yana move around a fixed position without changing their motion. You have to try to do this practical. Take either the bike, my dear student, and inue juu, kisha inua juu, alafu jaribu kuzungusha. Utaona kabisa kwamba kuna fixed position, lakini lile tairi litakuwa lina move around a fixed position without changing the original shape. Another is the circular cutting saws. This cutting saws they move in a circular form. It means they obey the concept or the principle of the rotation motion, because they move around a fixed position. Tunaona hata wale wanaojaribu kunoa hivi visu kwamba anakuwa kile kichuma kinakuwa kinazunguka. Inapokuwa kinazunguka pala, akisogeza kisu ndio kinaondoa ile kina remove the outer part. Mwisho wa siku kisu kinakuwa ni very sharp. This is a many of the examples of the rotation motion. Also, we have this sailing fan blades. We try to see this fan blades. Hata hizi feni tunajaribu kuziona. They try to move around a fixed position. Ukiwasha feni yako afu kiangalia inakuwa inazunguka. Inapokuwa inazunguka, kumbuka inakuwa inazunguka around a fixed position without changing their shape. Kwa hiyo inakuwa inazunguka pale pale, inapuliza upepo pale pale, inakuwa inazunguka kwenye sehemu ambayo imebini fixed, inakuwa na around in a circular form. This is what we say the examples of a circular motion, my dear students. Examples of the rotation motion. Also, there's another example that we have the most chairs. Some of the chairs they tried to move. Ukikaa kwenye hivi viti, kuna baadhi ya viti unakuwa unazunguka pale pale, kwamba zinakuwa ina obey the rotation motion because they move around a fixed position without changing their shape. So each of these examples involve a body that rotates about an axis that is in a stationary or in some inertial frame of the reference. All of this we tried to see here is an example that involve the body. This mostly they involve the body that rotate about a fixed position, or rotate on an axis without changing their original shape. It means they firstly they have an object or a body that is in a stationary in some reference frame. Kwa kitu ambacho kinabini fitted pale kinakuwa kipo kwenye stationary, lakini ile object inakuwa ina rotate kukizunguka kile ambacho kipo kwenye stationary. That is what we say about the rotation motion. So after there, let us look for our new subtopic, which is called the center of mass. On the center of mass, we are going to look the definition of a rigid body. Sasa tumeona topic yetu imeandikwa rotation of a rigid motion, and we tried first to look about the rotation motion. Now it is time to know the meaning of the rigid body. What is the rigid body? So rigid body is defined as the solid object that does not deform or change their shape under the influence of force. Any object that cannot change their shape under the influence of force tunaita ni rigid body, ni solid object, kwamba ni kitu ambacho kipo kwenye muundo wa solid ambacho kinakuwa kina move around a fixed axis without changing their shape even if the influence of force is applied, kwamba hata ikitokea umeapply force gani, kile kitu kina uwezo wa kumove pale pale bila kubadilisha shape yake au bila kudeform. That does not deform as we try to see on our definition here. So this is how you can define the rigid body, that the solid object that does not deform or change their shape under the influence of force. Even if you apply the force, for instance, pale tumeona ile wheeled bucket. The wheeled bucket tried to obey the to move around a fixed an axis if under the influence of force, lakini shape yake inakuwa haibadiliki, iko pale pale, kitu kinakuwa kinazunguka pale pale, lakini shape yake inakuwa haibadiliki, inakuwa inabakia pale pale. That is why we talk about the rigid body. So in simple terms, it is an object where the distance between any 2 points within it is remain constant no matter what force is applied. So sometimes we say that this is an object where the distance between any 2 points, it means kwamba the point where an object they can rotate to the point to the it means to the certain point inakuwa ni the same, they cannot change, ile distance inakuwa ni sawa. Tuangalie, tu imagine we have this disk VDC VDS ni VDS hizi tumejaribu kuziona hizi disk, kwamba ile distance kutoka kwenye ile fixed point mpaka kwenye ile circular form inakuwa haibadiliki, inakuwa vile vile even if the influence of force is applied. That is what we say about the rigid body. So a center of mass of a rigid body or a system of particles refers to a point at which where mass of the body or a system particle is assumed to be concentrated. When we talk about the center of a rigid body, after understanding the meaning of a rigid body, now let us try to look about the center of a rigid body, the center of mass of a rigid body, as the way our subtopic said, the center of mass. So the center of a rigid body, this refers to the system, refer to a body or a system whereby the particles, whereby the system of the particles is assumed to be concentrated. This is the point whereby the system of the body is assumed to be concentrated. Ile particle yako tunakuwa tuna assume kwamba inakuwa ipo kwenye center pale ambapo ile system tunakuwa tuna imagine imebini concentrated, imebini assumed. That is what we say about the center of a rigid body. Is where the object can rotate. Is the point where the fixed axis starts or the fixed axis retain, or the point of the fixed axis tunaita ni center of mass of a rigid body. So it can also be defined at the point. Sometime hii tunakuwa tuna define ni kama point at which the mass of the body can be considered to be concentrated when applying an external force. We shall go and look practically using the image or the figure that represent the concept of this center of a rigid body. We say that this is the point at which the mass of the body can be considered to be concentrated under the external force or under the application of the external force. So after there, my dear student, let us look at that. After looking, let us see the center of mass of any object. We have more object, many object, my dear student, that involve it is own shape or it is own center. So this is the average position of all particles. The average position of all particles of mass that make up the object tunaita ni center of mass of any object, kwamba hii ni average position of all particles that of all particles of mass that make up the object. So hence the center mass of regular shape object is like this one. Here, my dear student, on the rotation of a rigid body, we'll try to go and see a different object. Most of them, they have the regular shape, and many of them, they have an irregular shape. For those who have the regular shape, tunaziita hizi regular shapes. Mfano wa regular shapes kuna hizi rods. We shall try to go and see the rods. Also this desk that have the regular shape. It means the shape is known. The shape is determined. The shape can be labeled, can be understood. So that is why we say about it the regular shape. Inakuwa kitu ambacho kinakuwa na shape maalum, tunaviita ni regular shape. Tulisoma sana sana kwenye solid, tukasema kwamba solid can be categorized into two types. We have the regular solid and also an irregular solid. In Form 1 we try to see this concept. So my lovely student, this rod, this cylinder and also the sphere have the regular shape. This is the money of the example of an object which have a regular shape. Is at the geometric center of the object. Kwa hiyo hapo inakuwa ipo kwenye geometric center of an object. So my dear student, for an irregular object, after looking at the concept about the irregular object, now let us see an irregular object. An irregular object, this is an object that have a known shape. Zile object ambazo zinakuwa shape yake haitambuliki sana, tunaziita an irregular object. So it is center of the mass depending on the shape and the mass distribution of what is a particle. So this irregular object, my dear student, it is mass depending on the shape and also the distribution of the particle. Kwa hizi hapa shape yake, ile mass yake uweze ukadetermine, inakuwa inategemeana na ile shape ya object pamoja na ile distribution of the particles. Kwa sehemu ambapo utadistribute ile particles ndio tutadetermine kwamba hapa mass yake imebini concentrated, lakini sehemu ambayo pia utaweza kudetermine kwamba shape yake iko sehemu fulani. So consider an irregular object of mass m consisting a larger number of particles each having the mass of here. Let us assume we have the irregular object, and this irregular object, my dear student, contain or consist their masses. It means having their masses. It have the mass 1, mass 2, mass 3, and so on. This indicate the rotation of the particle about an axis at the that occur rotation occur at point OP. Let us go and try on the figure number 4.1. So this is our figure here that explains the rigid body of with the axis of rotation OP. We have this center which is called the OP here. The OP, this is the point, and this indicates the center of rotation. And we have the mass here. This is an irregular object. And this irregular object, my dear student, contain its own masses. Kuna mass at this point, and also we have the mass at this point we call as the mass 2. Also we have the mass at this point ambayo tunaita ni mass 3. Now we see the distance from the axis of rotation to the position where the mass is distributed. Pamoja na hii hapa tunaona kuna x1, kuna x2, kuna x2. Hizi zina indicate the distance ambayo ile object imebini concentrated. And we see that this irregular shape, irregular object tried to move around the axis, around the fixed axis. They try to rotate on him. It is an axis around the OP at the distance x1, x2, and also the x3. So my lovely student, here each particle experiences an external force. As we see that each particle that are found inside the irregular object or irregular shape here, they experience its own external force. So in order to get this force 1, we must take force 1 here. The force that act on the mass 1 should be equals to mass 1 times the acceleration. Lakini huyu force 2 hapa around this second particle, force 2 is equal to mass 2 times the acceleration. Lakini kumbuka ile acceleration ina remain constant kwa wote. Lakini for body 3 itakuwa force 3 is equal to mass 3 times the accelerations. And also if we have so many masses, now we can say that for any masses, it means for any irregular shapes, for any point of all of the particles, we could say that force n stems is equal to mass of the n stems times the acceleration. But the total force experienced, sasa tunapataje ile total force experienced? Tunasema total force experienced itabidi represented by F. It means force is equal to mass 1 times the acceleration. If we add by mass 2 times the acceleration, then we add by mass 3 times the acceleration plus dash dash mpaka kwenye mass tunapokuwa na mass nyingi, mass of the n stems times the acceleration. This should be the equation number 4.1, equation number 1 on this topic. So by saying that, my dear student, this is the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.